Okay.
Okay.
So for part one, p hat equals x over n. Your x is the number of successes, and then the n is your trials over
Right.
how many are in. Yeah.
Hmm.
And then the formula p hat plus minus z star, which is the 95%, 99 or 90%. Square root of p hat parentheses 1 minus p hat over n.
Which formula are you doing for number two?
The p hat plus minus z times square root.
Oh, so you wouldn't necessarily do that for the confidence interval. For the confidence interval, it's just. Oh wait, yeah, you're right. Sorry, I was looking at the wrong one.
Oh, okay.
My bad.
Oh,
Been one of
It's
those
okay.
days.
oh yeah.
Yeah, you got it.
And then 3n times p hat is greater than or equal to 10. And then n times 1 minus p hat is greater than or equal to 10. Then it would be yes, the confidence interval. So um, then 4 n equals z times, no, z star over 2m, and then square that. M
Yep.
is your margin of error.
Yep.
And then for 5, your z score equals p hat minus p, which is the population, right?
Yep.
Yeah.
Over square root of p times 1 minus p over n.
Yeah. P is the true population or true proportion of the population.
Uh-huh. And then for 6, I got the same thing as I got for 3.
Yep. It's like restating the same question, basically.
Yeah.
Okay. And then, so part two, you have 684 of 100 or 1,006 randomly selected college students that have been involved in an automobile accident. I thought that was kind of high, like
Mm-hmm.
that probability. I don't know. It's probably because
Well, within the last 5 years, that's like high school.
true. Yeah, I guess. I
So,
guess that's kind of true.
I don't know. High school kids drive crazy.
Yeah. Okay. So A, find the proportion of those surveyed. So it's just doing the x over n. So 0.680. And then the requirements, just take in 1006 times 0.680 to get 684.
Mm-hmm.
So it's greater than 10, so it passes. And then the margin of error, I didn't write down my work. I
Margin of
got,
error is 0.6. Hold on. Which one are you on?
we're on 1C. I got 0.029.
Yeah, me too.
And then D, my interval from what Excel said was 0.651 on the lower and then 0.709.
Mm-hmm. Wait, let me do that again on Excel real quick.
Okay.
So the x we have as 5.
Yes. Well, no. 684.
Oh
So
wait,
the
the x is 684,
yeah, and then the N is 1,006.
and then confidence interval 95%.
Yep.
Okay, yeah, yeah.
Okay, and then in college students, see, then you plug it into that sample size formula.
Mm-hmm. So
You getting
use
it,
Z.
Maria?
Yes, I am. I'm sorry that I'm being so quiet, but I'm really following along, I promise.
Okay. And then, yeah, so then I got 4,269.
Yeah. So do we always round up no matter if it's like 0.01?
Yeah, so if it's asking you for sample, then yeah, because you're not gonna have like a portion of a person.
Uh-huh.
Right.
So, but I believe it said when doing sample sizes, just always round up. So even if it's not a person, if you're doing like something else, if it's
Oh,
0.01, then you always go up no matter what.
Mm-hmm. And
Okay, so
hypothesis test.
A, I had the null is 0.60 or 60%, and it equals 60%, and then the alternative is greater than.
Uh-huh.
And the Excel gave me 5.174 for your test statistic, just
Mm-hmm.
high. And the p-value is like basically 0 because it's so far away. Then you reject the null, and there's sufficient evidence that more than 60% of students have been in a car accident.
Mm-hmm.
wow.
Sound about right?
Yep.
Yep.
Okay, should we start the group quiz?
Yep. 1 and 2 are both true.
Hold on.
There you
I'll
go.
pull it up.
Participated.
So 3.
That's just P, right?
Yep,
Yeah,
Cool.
P.
it's definitely not P with the squiggle.
Yeah, I think that's called something in Spanish, but I couldn't tell you.
That would be an
Yeah.
N if it was N.
Oh.
It's like,
But
yeah.
there's no such thing as that in Spanish for P.
Oh. Oops. Never mind. It doesn't even have to be
Okay.
that.
That happens. Half of BYU Idaho speaks Spanish, so.
Gotcha. Yeah. Okay, so then 4 requirements for constructing a confidence interval are satisfied.
So you need an X and you need an N.
So to do the confidence interval, you use the p hat and the n.
Oh yeah, so you could find your X.
Well, it just wants to verify that it's greater than or equal to 10, which in this case it would be. If you do 0.10 times 100, you'll get 10.
Mm-hmm.
Right.
So that's true. And then for conducing
Inducing.
conducting a hypothesis test, then you use the p-value for that one,
Yeah.
which you'll get 25. So we're good to go on that one.
Cool. That's what I was hoping. That's what I put.
Hey guys,
Oh,
Hey.
hey!
I
Hey,
didn't realize what time it was. I was like, oh crap.
It's okay.
we're like we didn't get any email from you, so we're like,
You probably did the homework.
Yeah.
Alright,
but
we're on the group quiz on question 6.
Okay, let me open the quiz.
okay.
Yeah, I looked at the clock. I was like, crap, it's 7:45. is lesson 17, right?
Yeah.
Okay. Yes, true, true.
Yeah. I have a question about our study, Tanner. But we can talk about it after the group quiz.
Okay. The true population proportion is p hat or just p?
It's just P.
Just
It's
P.
just p, and then the sample's p hat.
Yep.
Yeah.
Okay.
4 and 5 are both true.
Yeah, because you do that np is greater than or equal to 10
Yep.
equation. Okay. And we're on 6.
Yeah.
Okay.
So P hat, you just take the 45 divided by 60.
Yeah.
0.75.
Right.
I don't know if 0 matters or not. But,
I've always put the zeros all semester, so
okay.
yeah.
And the confidence interval from what Excel said, as long as I did it right, 0.640 to 0.860.
Okay.
Yeah, that's what I got.
And then if you increase your sample size, then it would decrease.
The
Right.
width.
Right.
Yeah.
Conduct a hypothesis test. Suppose P is 1/2.
Oh, okay. Suppose it's, what's the smallest n can be?
And 10 divided by 0.5, so you get 20.
20. This should be right.
And then 100 for 10.
Yeah.
Okay. So 11's true.
So when we do those, do we have to do the np and then the n times 1 minus p also?
Let's see. I guess it is, and I guess you have to do both of them. I always just do one of them. But I guess because I always thought it said or, but in this case it does say and. Dang it.
It matters later on is the only reason I was pointing it out
Oh, okay.
for these next upcoming lessons again.
So I know it was true on the first one. Was it true on the second one as well?
That's what I was going to check. So that'd just be, what, 80 times 0.4 instead? Which would still be true.
Okay.
You'd have 32 is greater than 10.
Okay, cool. And P 38 divided by 80, 0.475.
Yep.
Yep.
Yeah.
And then negative 2.282.
And then the little output. This one's just one tail though, right?
Yeah.
So 0.011.
Yeah, for the p-value.
Yeah.
Yep.
And that would be reject the null.
Yes, sir. And then, so sufficient evidence to conclude that water quality in the area has decreased.
Yep.
Back on 13, when you put in the formula, You had 0.475 minus 80? No. What was your P? Oh, 0.6. Duh.
Minus 0.6 over the square root of all that.
I guess I could try the formula.
I'm gonna try it real fast just because.
Yeah, I just was reading it from Excel.
Yeah. $80. The root of that is. Bottom is 0.0546. Divided by 0.05. What did we end up getting? Negative 2.282? Yeah, that's what I get still.
Yeah.
Well, we got 100.
Yeah, I was like that. I was like, that's what I get anyways.
Yeah. I was like, I think we're pretty solid on that one. So yeah, we got 100.
Yeah.
Sweet.
For a heads up on the lessons for the next week, lesson 18 takes a long time.
Does that?
Okay.
19's not bad at all.